So welcome to the session D335, Modularization Strategies and Examples. My name is Iryna Mozgova. I'm from Leibniz University, Hannover. And allow me to introduce our speakers and topics. You can see the title of presentations already in your screen. So we have 5 presentations. We will start with first presentation, copying asynchronous modular product design by modeling a system in system. And first presenting author, Marc Zuefle from Hamburg University of Technology, Germany. Marc has been a research associate at the Institute of Product Development and Mechanical Engineering Design, and he conducts research on modular design and methodological support of collaboration across disciplines. Topic of the second presentation, modularization metrics, contracting industrial praxis and state of research. And our second speaker, Dan Lennartsson from Jönköping University, Sweden. I hope I make my pronounce okay. So for the name of the university. Dan is currently a PhD student involved in modularization research in an enterprise context, working in the areas of product and production development, computer science, and informatics. He has worked several years in product development, manufacturing, and supply chain, and also 20 years of experience as a global modularization. So we have expert between us. So this third presentation deals with the topic of modularization maintenance for improved production impact clarification. And third speaker, Julie Krogh Agergaard. Julie is a PhD student in the Department of Mechanical Engineering and Technical University of Denmark. She has a background in design engineering and has studied the application of architectures and modularization in maintenance for the last 4 years. Topic of the fourth presentation, validation as a new evaluation method of modular design focused of the prosumer. And our fourth speaker, Laura Asión-Suñer. Laura is a PhD student in the Design and Manufacturing Engineering program at the University of Zaragoza, Spain. She is also head of project planning and product designer, and she is also active as a teacher, if I understood correct, in the master degree in direction and management of resources and social services. And the last presentation, towards an optimized value creation network for modular investment codes, concludes the series of paper in our session. And Tobias Seidenberg will introduce this subject. He studied mechanical engineering with a focus of production and management, and is an expert in development methodology and management at Fraunhofer IEM in Germany. And his expertise is reflected in larger number of research and industry projects. So now we will have opportunity to listen video for all 5 presentations. And parallel, you can write already your possible questions in chat. I have also, so please write also with your question the name of person who you address your question, or maybe the number of presentations, so we can easily recognize who should give answer for one or another question. And I hope after this video we will become interesting discussion. So now, please, Fanika, we can start with presentations, videos.
Hello, everybody. Welcome to our presentation of Coping Asynchronous Modular Design by Modeling as Systems in System. My name is Marc Zuefle. I'm a research assistant at the Institute of Product Development and Mechanical Engineering Design at the Hamburg University of Technology. This research was done in cooperation with Trumpf Machine Tools SE and Krogh AG. First, we want to give you a brief introduction and motivation on our research. So, the complexity of products is increasing, and this leads to a rising relevance of transparency in product architecture design. Megatrends, for example, are drivers for complexity. And if we look at connectivity as a megatrend, we can compare this with the mowing robot on the right side as an example. This is not only a mowing robot, it's an smart system by Gardena, because the mowing robot is interacting and connected to other systems, external systems. So this robot needs the ability in its architecture to be able to talk to other systems, to interact with other systems. So it needs more influences by other development disciplines as software control or others. And this is the second point, the expanding integration on development disciplines. So there's a trending shift from multi to cross-disciplinary, and there's also an impact on the methodical development. So as known, the modular design is one possible way of coping complexity in product architecture design. But the additional development disciplines increase the amount of coordination to achieve transparency, what we want to achieve. So we started with a case study to investigate the circumstances. And this research was conducted with the case study of loading and unloading automation, as you can see in the pictures on the right. On the left side, you can see all the circumstances and high external variety, increasing relevance of software, and low transparency of internal variety. But as a basis, this system was prior modularized by the design for variety method by Kip and the live phase modularization by Blaise. On the left side, you can see the result of this modularization. So as a basis for this case study, we found out that despite the modular design, this system has a lot of more problems, additional problems of the modular product family as it stands on this left side, because there's an intense collaboration effort between these development disciplines. And there's a simultaneous and uncoupled discipline-specific design process with a high effort in system integration then. And you need additional changes for integration so that the system fits and can be validated. And if you look at the left side, this is the result of the prior slide. We look at this nearly swim lane diagram we did. So we have the different disciplines and we have the different module cuts, and these module cuts are not harmonized. So this makes a problem in system integration later. And what did we do? We observed then that even what I mentioned, that despite methodical support development, modular product families, as we did, there's mainly mechanical components are affected. So the other disciplines have developed asynchronous modular designs, and this is what means asynchronous modular design in our title. So what did we do? We depicted it here in a picture, in a figure, that the different module cuts are a problem in integration. And the hypothesis then is that modularization can be improved by harmonization of specific modular design. So this means integration of other views on cross-disciplinary design for variety and to form uncoupled and almost self-sufficient subsystems in an observed systems, as we call it here, as systems in system. So we want to simplify the integration into the overall system by decoupling and uncoupling those systems. And we want to do this by integrating other disciplines, electrics, fluidics, in the design for variety method, as mentioned before. And what is our goal? Our goal is to harmonize the module cuts as depicted in the figure on the right side, which we call then systems in system. If we look at the application of the adapted method, we started with the decipher variety method by Kip, and it was adapted on a cross-disciplinary system. Cross-disciplinary system adaptation is seen here in this picture. As you can see on the P level, there are different disciplines added to the level. And on the L level, on the logical level, you can see that the variant principles are mentioned with different visualizations due to the different disciplines. And this can be seen in this picture here. This is the cross-disciplinary adaptation of the method, the design for variety by Kip. And you can see that every discipline is integrated in this method and is integrated with its own visualization of the logical level. So what is our result? Our result was harmonized cross-disciplinary modular design concepts. So it's only concepts, but concepts with cross-disciplinary couplings, which can be made transparent, overarching linkages that can be investigated, and harmonized subsystems that can be concepted. So as you can see here, from the second level, the modularized system, to the third level, the modularized, let's call it systems in system, to split it a bit, you can see that the harmonization is way better in this conceptual view. So at the end, let's say we have these three stages, and on the right stage, there's a concept of systems and systems with less connections between the systems, between the subsystems and modules, which makes the integration better and the consideration of other disciplines. On this final slide, we want to make clear that this is not a substitute for the development of discipline-specific architectures or components. It's just an additional way on looking on multidisciplinary design processes in a cross-disciplinary way. And we want to show that we already identified potentials like the transparency, which is displayed much better, concept designs, and possible savings on top. But we have to do further investigations, new use cases, new case studies, new concepts, and investigating the processes. So last but not least, we want to thank you very much for your attention.
Modularization metrics contrasting industrial practice and state of research. The authors of this paper is PhD student Dan Lennartsson, who has 20 years experience of modularization globally, assistant professor Dag Raudberget, Professor Ulf Seigerroth, and Professor Kurt Sandkuhl. The intended contribution of this paper are analysis of industrial real-world cases to capture commonly used practices and requirements, compilation of metrics in the context of modular product design from research, identification of gaps in industrial and research view on metrics with focus on modularization strategy and economic effects. Contrasting modularization metrics in research and practice, research gap. Based on the observations from the industrial cases presented in the table here, we see a need for additional research on modularization metrics. No established practice that what metrics to apply in what step of the modularization process. Research offers a rich body of knowledge on modularization and relevant metrics, but the industry only use a fraction of these metrics. Based on discussion with practitioners, our view is that many metrics are considered as either difficult to implement or difficult to interpret, as they are too fine granular. Value disciplines as strategy for modularization. These three disciplines can serve as a base to define and make different metrics operational within each discipline and as enterprise quality criteria. The three disciplines are often unique for each product and provide the basis for metrics to use for a specific modularization initiative. The potential return on investment for modularization initiative can then be calculated using the value map method by Larsson and Åslund 2001 and ROE through using return on capital employed. Summary of the 3 case studies. These 3 case projects resulted in material sufficiently rich to be analyzed in a scientific paper. Case A, domain train supplier, modularization focus train coupler, applied techniques business case plus KPI, MFD module production. Case B, domain industrial equipment, chain conveyor, business case plus KPI, MFD external supply chain. Case C, automotive trucks, truck variance matrix. Modularization of train coupler. The work procedure that we applied in this case was divided in 4 general phases: scoping a business case, module concept development, module and interface design, and manufacturing system design. Business strategy and modularization goals and metrics. The KPI that was decided for train coupler project is in the table. Strategy, operational excellence, metrics, shorter time to customer, goal coupler 4 weeks. Strategy, operational excellence, increased reuse of development resources. Goal coupler, 70% reduction of development hours. Strategy, product and leadership, new technologies, double acting damper, internet in cables. Product leadership, increased reuse of components, 50% reduction of article number. Customer intimacy, more product variants, 4,000 new products. Customer intimacy, increased customer satisfaction, no problems in the field. Modularization result case train coupler. Industrial goal was to be more competitive by reducing product and production costs and to enable the introduction of new technologies. The shorter time to customer and reuse of development resources was not met during the project since some modules variants were not developed until required by customers. When a need for a new module variant comes, it is developed using the already defined designed interface. The full potential for reducing design hours is not achieved until all modules are designed. Production metrics for the train coupler. When the module system structure is ready, it is possible to build the production with module areas with a final assembly in the end. All starts with a QFD for production. Metrics properties are tied up capital reduction, lack of quality cost, delivery precision, blue collar workers, less for cost for contract manufacturing. Each module area has a testing in the end. Metric summary for the 3 cases. Some of these metrics are straightforward to operationalize. For example, part number reduction. Others are composed of several indicators, for example, shorter time to customer, new variants. And again, others are difficult to capture and implement, for example, organizational knowledge development.
Hello, my name is Julie. I'm a PhD student at the Technical University of Denmark. I'm here to present the paper Modularizing Maintenance for Improved Production Impact Clarification. Now that's a bit of a mouthful, so let's start with why are we even trying to improve production impact? And so here I've got an example of one piece of equipment in a production flow. So the piece of equipment has production flow in and it has production flow out. Now let's say we're going to do maintenance on this piece of equipment. The equipment is broken, we need to replace it. So we need to take it out of production. And so we have impact on the production flow because we took out a piece of equipment in order to put in a new piece of equipment. And when we do this, it has impacts, first of all, of course, on our costs, especially if we have a large continuous production or almost continuous production. When we take out a piece of equipment and have less production, it's going to have an impact on the amount that we're able to produce. It's also going to introduce safety concerns. We're not running our production line as we designed it to do. And in the same vein, when we're not running it as we designed it to do, we also have a larger potential for emissions. We're interfering with the production line, and so we might have emissions when we start changing things. And so you might say, well, oh, when we have one piece of equipment, this is very easy to see what is the impact of our maintenance. However, when we have large amounts of work, if we have really big facilities where we do hundreds or thousands of jobs each week, 2 weeks, it becomes really difficult, especially because in maintenance, we need to understand multiple dimensions, especially the physical dimension, the action dimension, and the process dimension. And the information in these 3 dimensions is only partially standardized. And so we may understand that we have corrective maintenance or preventive maintenance, but maybe we have different ways of describing lubrication. We might say either lubricator, grease, etc. And these were similar challenges we saw in the research group to what we tackle using product architecture approaches. And so in product architecture, we handle large product portfolios across multiple dimensions with little to no sharing currently across the large product portfolios, or at least very little understanding of what we share. And so we defined maintenance modules as independent maintenance activities that are defined by these 3 dimensions. The physical dimension, which is where is the equipment located? How is it dependent on other pieces of equipment? What type of equipment is it? What are the classifications? And also, what is the environmental context? So how much is it used? How much does it wear when you use it, etc. The action dimension describes what is the action we're taking? What type of work or skills do we need to take the action, how much time, all these things. And the process dimension describes where in the process of planning and executing and closing out this job are we at this current state. And so the interfaces between our modules, the independent maintenance activities, are the connections and dependencies across these dimensions. So an action might have a different impact on the production depending on physically where the piece of equipment is situated. And so going into each of the dimensions, we talk about the physical dimension mainly as the technical system decomposition. And so understanding from the plant level all the way down to the component level, what are the dependencies of our equipment? If we have an impact here, then we have an impact on everything below that in the hierarchy. We also understand the action dimension in the context of production impact. We understand whether the action that we're taking has impact on production. Some actions might also require the equipment or the production to be active, to be running, and some actions require either or. So there's no impact on production. And finally, is the process dimension. And so we define these 5 steps: identify, plan, schedule, and execute and close out, where, for example, schedule is probably where we can best identify our production impacts, because we've already identified the need for maintenance and we've planned what actions are we taking. So we know what are the sort of impact on the production. We just need to define when to perform our maintenance. And so looking across these 3 dimensions, we can see, well, looking here maybe to the physical dimension decomposition, here on level 2, we have a node that has a maintenance activity happening where the action requires a production impact. And because of the nature of the technical system, we will also have an impact. When we have an impact on this node, we know that it'll affect all the components beneath it. And so looking to the other maintenance happening in these nodes, we can see, oh, well, maybe this one that also has a production impact. We need to make sure that these are happening together to minimize the impact that we have on our production. And we maybe want to make sure that this one that requires the production to be running won't overlap with these other two jobs. And so this is possible because all our jobs are in the scheduling stage. If some of these jobs were, say, in the closeout stage and we had already executed them, of course, they wouldn't be compatible. And so this is how we sort of define the interfaces, the commonalities across maintenance to make these decisions on the impact. And so we applied this in industry, in an oil and gas context. We created this interactive dashboard where you can go from field down to system, or on the plant level, you can see each system, and then each system is described by a drawing. And on the drawing, you can see individual pieces of equipment. And so that's the level of detail that was needed in this case. And so you can click through the technical system. At each level, you're always able to see what are the maintenance happening at this level, so that you can always see, you always have an overview, what's happening. You can filter through by the action impacts, etc. And in the current process, achieving an overview such as this one, where you can see all of your impacts, you can filter by the type of impact, where in the process you are, etc. It requires a very iterative process of multiple meetings and then going back to your desk and looking through SAP, which can take multiple hours just to find this similar list. But introducing this type of approach in the company, we are able to improve this process where these types of opportunities can be identified during a meeting, and that can take less than 10 minutes to identify, and you can scope together and find the final list. Yeah, read more in our paper, and thank you for listening.
Hello, my name is Laura Asión, and I am a PhD student in the University of Zaragoza, Spain. Before starting, I'd like to thank the conference organizers for their work and for the opportunity to present our work, which has the title Validation of a New Evaluation Method of Modular Design Focused on the Prosumer. The modular design harbors a potential development in the prosumer scope that has hardly been previously exploited. The joint application can lead to products focused on user participation. For this, modular design offers a series of advantages directly related to the needs of these users, such as adaptation, customization, or update of the product. This work proposes and validates a concept evaluation metric in the design phases that meet these characteristics. To do this, 24 external designers and prosumers evaluate 5 products using this method. The results and conclusions contribute to the improvement of the method and provide information on how to approach it to the prosumers. The research is established on a previously defined evaluation method based on a checklist. It evaluates 9 characteristics, 3 of modular design, 3 of modular design and prosumer, and 3 of prosumer. Each characteristic was posed as a question, and each level to evaluate has an answer, with a total of 5 levels ranging from 0 to 4. These were the products chosen for the evaluation. Taking as a reference a previous evaluation of 35 products realized by the researchers, it was decided to select 5 of them based on the results obtained. The objective was to validate the initial hypothesis by matching the professional evaluation with the researcher's proposal. So that the evaluators could apply the method correctly, a user guide and an introductory video were developed. Both introduced a series of key concepts: modular design, prosumer user, and method functioning. In addition, the guide also included a list of references with real examples of each level of evaluation to facilitate their choice. The method was transferred to an online form so that each evaluator could respond individually, thus ensuring correct usability and data collection. As a selection criterion, it was imposed that all evaluators must have more than 5 years of experience in the product design sector or in the maker field. In the case of prosumers, the evaluator also had to belong to a maker organization. All the evaluators were of Spanish nationality, and the ratio between female and male sex was 50%. The following table presents the results of the evaluation of each product. All characteristics show a rating from 0 to 4. The table also shows the total assessment of each of the 3 areas out of a maximum of 12 points, 4 for each characteristic. Thus, where the results should be higher according to the previous evaluation have been highlighted in bold. According to the results obtained, we can conclude that the evaluation carried out by the researchers and the evaluation of the 24 professionals coincide in the most outstanding points of each product. Despite these coincidences, we see that there is still some lack of precision in the results. There should be a greater difference between some products. It was also analyzed the convergence in the results to reveal whether there is consensus in the perception of the products, as well as in the understanding and application of the method. This table shows the level of convergence by colors and percentages between the results of the 24 evaluators for each of the 9 characteristics. If we analyze the columns of the table, we can see which products have been easier for the evaluators to rate. On the other hand, there was provided information on which characteristics are best defined by the convergence of their results. We found that variable and customizable are the clearest characteristics for the evaluators, while independent, upgradable, and moment of intervention have generated most doubts. The last result obtained was the feedback from the evaluators. Regarding the profile of the evaluators, we find that around the 71% are designers, while the 21% are prosumers, and the 8% of them are makers. The majority of them assigned to the method a medium level of difficulty, while 25% considered that the method has a high level of difficulty. Half of the users considered that the method was of practical interest to them, while 42% answered that they would use it depending on the circumstances. We can say that most evaluators find practical interest in the method. The purpose of the validated method is to use it on the conceptual phases of product design. However, it could serve also to improve commercialized products. It is observed that it could be necessary to review the metrics and evaluate products belonging to the same industrial sector in the 3 areas. Although some evaluators consider the explanation adequate, they believe that they need more information to apply the method. Finally, the study shows the following conclusions. The use of a getting started guide and an introductory video have greatly facilitated the final application of the method. On the other hand, it was more difficult for the evaluators to understand the sections of the guide where there was more information, so it is preferable to provide small doses of information. Despite the interest generated by the method in the design field, it is difficult to bring tools like this to the maker field. Non-specialized environments are not used to using design methods. The convergence between the results of the researcher's evaluation and that carried out by the professionals verifies the functioning of the method. At the current development point, the features clearer to the evaluators are variable and customizable. However, it is necessary to provide a more precise definition for upgradable, independent, and moment of intervention. Thank you very much for your attention.
Ladies and gentlemen, warm welcome everybody. My name is Tobias Seidenberg, and today I'm presenting you our paper with the title Towards an Optimized Value Creation Network for Modular Investment Goods. The paper was written by Elena Schroeder and Lydia Kaiser from the Technical University of Berlin, and Jan-Philipp Disselkamp, Harald Annaker, and myself from the Fraunhofer IEM in Paderborn. I'm not wasting any time with an agenda, but start directly with the motivation. We are dealing with this topic because we are participating in the project TRAM, which is funded by the EU in the Horizon 2020 program. TRAM stands for Transport, Advanced and Modular. We're trying to develop a fully electric, modular, high-speed ferry. And we're not only modularizing the product itself, but we're also developing an optimized value creation network. And with this, we're trying to reduce the costs of the production and development overall by 25%, reducing the time for the development by 70%. And we are also obviously doing a zero emission ferry, so we are not polluting the air anymore. So we've got a 100% avoidance of toxic emissions, and we have got the reduction of energy consumption by 30% per passengers. And this needs to be done because of the rising urgency in changing conventional ferries in fully electric zero-emission ferries. And the traditional shipbuilding is just not fast and efficient enough to provide these ferries to a competitive cost. Therefore, we're trying to do modularization. However, for modular investment goods, or specifically for investment goods, there are some challenges in the modularization. As we see, the production costs make just overall between 15 and 70% of the life cycle costs over 10 years. Here we see the total cost of ownership of a ferry on the right side and of a truck on the left side. We see they are very comparable. In both cases, the energy or fuel costs, for example, make a quarter of the total cost, and the crew cost around 40%. So the production costs just make a small share. However, for the shipbuilders in Europe, this small share is what their business is. So we need them to be competitive in the global market. And we can achieve this by using the benefits of modularization, like the distribution of production and development, the specialization of suppliers, as well as the parallelization of development and production steps. This has been done for other industries as well, and we want to design a production network based on the findings of other industries. Therefore, we're looking into, for example, the automotive industry or the aviation industry to not start with a blank paper. We are asking ourselves, how did the modularization of the product in those industries change the according production network? And it's not only that the production technology has changed in those two pictures, the organization is very important as well. So based on this, we can then design, after we understood how the modular product has an impact on the production network, then we can, in the future paper, design the actual production network itself. So this is part of another paper. Here we're just discussing how this target picture should look like based on the experiences made in other industries. So therefore, we are proposing this 4-step method. As you can see, we're starting by collecting all the relevant data that we need, all the information, putting them together. Then we are at the comparison of the product. Then we do compare the production network. And then we are investigating what are the actual changes that need to be done. So starting with the collecting of the relevant data. At the beginning, we had a long wish list, but we came to the conclusion that most of the data is just not available public. So obviously, we needed to make some compromises there, and we decided to go with data that is actually available or it's available also from different sources, references, because then we can be sure that there are no errors in the data. There were other information available, but only just from one specific reference, and that was just not enough for us to be sure that there is no error. So after collecting all the data, we did the comparison of the product. So basically, we investigated how did modularization change the number of variants and how did it affect the product efficiency. As you can see from the last century, basically the number of variants in the automotive industry, for example, grew drastically. And we're seeing a similar approach here in the shipbuilding industry. So we can compare how did the metric change for our benchmark, the aviation and the automotive industry, and so we can say how we expect to change it in our case. In the third step, we're talking about the comparison of the partner network, where we're doing an ABC analysis. We're analyzing the vertical production depth. The research and development investments gave us a lot of insights. And furthermore, the actual production network structure changes. So for example, how is the distance between the suppliers? In the last step, we're then actually understanding or doing the synthesis on how the production network changes are there, what did happen. Here's an example. We see that there's an integration partner that is working with the system partner, and that gets supplied by different supplier tiers. And the OEM, like an automotive manufacturer, is then only basically connecting all the things, integrating all the things. And so the way on how they're producing changed quite drastically. Coming to the conclusion. So for modular products, we can say that outsourcing certain products steps to suppliers with specialized equipment lowers the production costs and also gives us quality advantages. The parallelization of production steps reduces lead time drastically and is heavily needed for our needs. By distributing the research and development to specialized partners, we see a better result overall, lowering the energy use per kilometer, per person kilometer, and the high degree of supplier integration in a just-in-time or just-in-sequence developed network will lead to further cost savings. As the next steps, we're obviously trying to develop the method to design the actual network. And then we're validating this network that we're designing by building our demonstrator. As you see, the building of the demonstrator is already quite advanced. So we're now basically doing all the reporting and doing the reports and coming to a conclusion. That's everything from my side right now. I'm happy to answer any questions right now or reach out to me via email or LinkedIn. Thank you for your attention.
So, thank you very much for all presenter for this preparation work for this video. Thank you, Fanika, for technical support. We have now about 33 minutes for questions or discussion. Please feel free to write your question in chat. Or maybe if you want to discuss something with us, with all presenter, you can also push blue button in right side of Hopin framework, and after that you will have also possibility to activate your camera and microphone and formulate your question, or please write question in chat. So I propose that we start this discussion. We can see already again the slide with all 5 topics. I propose that we start this first presentation. Has somebody question to Marc? Okay. If not, I have some question. So in your research, you have exposed the possibility to integrating different perspectives into the approach of already existing method, like design of variety or modular design. So you try to investigate in this method some different disciplines. How do you assess the possibility of reusing the resulting solution? For example, in situation, if you have some solution for some existing system and you can recognize disciplines, so you try to develop another system, you recognize which disciplines are important for this system. Have you possibility to reuse already existing solution, or it will be difficult?
Yes, it's a good question because we are trying to investigate the product architecture in a way so that we can document all our findings for further research, for further production, for further designing. Because when we are applying the design for variety method as an example, we are elaborating more than one concept for the product architecture we are investing. So we're looking at the product architecture and investigating different allocations, different disciplines in this system or in the subsystem, and then we are trying to find some concepts by creating new components, for example, creating new solutions for logicals, for solutions for functions, and then we are documenting this in a separate. Yeah, let's call it. I think in our paper it's called an concept base, a concept backbone. We're documenting all this so that we can go back if we recognize there's a similar problem or something like this. So we're not doing the method just once so that we did it and we're fine and everybody is happy. We're doing this for continuous improving. And continuous improving with continuous documentation.
Okay, thank you for your answer. Maybe somebody have also a question to Marc. So, okay, maybe we can come back a little bit later again to your topic so that all presenters have possibility to answer possible questions. So we can move to second presentation. Have somebody question to done presentation? Okay, so I have one or two questions maybe. The first question is, have you investigated the impact on the proposed metric of the number of staff, for example, involved in development, or number of, shall I say, participants or companies in the production and delivery chain? Because I did not see these factors in your metric system.
No, we haven't checked that, but we need to do that in the future because this is will be really important to understand, because I think one of the main challenges in the future is to have the work for development of modular products more cross-functional, which means you need to work with teams all over the way, with production people, with different competences from electronics, from software, everything, I think. So I think this is really one key question for the future. It is a problem in the practical situation today because we have the what we call the organization like silos. And it's difficult to get this working. Usually you try to get this working with projects, but I would say if you can work with teams, it's much better. And in the future, I think what will happen is that we have a research project coming on, and where we would like to, we have a company that will have a new product for the market, and they work with these teams already because they are a new company going into the work practically, and then we can check these kind of things. So I think it's a good question, and it's something that needs a lot of more research in the future.
Okay, thank you, Don, for your answer.
Yeah.
So I have also some second question to your presentation.
Yeah.
And second questions about regarding modularized metrics and production and product leadership.
Yeah.
When it comes to accounting for new technologies, how will this metric system be affected by the use of several new technologies, or conversely, if only one of subsystem of product, for example, in product or in process chain or is in supply chain, has new technology, should use new technology, and another actually no.
Oh, yeah. Okay. I think what we did in this example that we talked about, the train coupler, it's we have two new technologies coming in there, and it was the double acting damper that can take the draft and the draft and also push. Then you need to you need to have that with you when you design the interface. And I think one of the main thing here is to understand that you need to design the interfaces. It's not only the module variants that you need to design. It's to understand that you need to design and have a simple and robust interface that works all over the product life cycle. And we had also in the electrical coupler, we wanted to have the internet going into the electrical coupler, and we have strong power there. And you get problem with the EMC when you do this. And we had to design the interface to cope with this in order to get the new technology inside this module variant and also into the interface. So for me, it's always the enabler for this is to understand what type of new technology and how that goes into the interface. That is the main thing. And you have to be very, very, very knowledgeable about new technology and how that works in the interface for the future when you do the design. Otherwise, you are missing one thing. So you need it very, very early, I think. I hope that was an answer on the question.
Thank you. So it was really good answer. So I can follow you and I can understand what you mean in this part of your metric system. Thank you. So have somebody question to Don to the second presentation?
I would actually have a question, just indirectly related to the presentation I have tonight, but still related. I was wondering, what do you think regarding like how important is software to actually utilize those metrics later on in an industrial project?
I think it's really important because my interpretation is that I would like to do the modules so I have the software in the modules already from the beginning, because that is for the production. When you do the module area, you want to have a testing in the end of the module area, and then you go into the final assembly, and that's why this is so important. So I think, and also for the smart products in the future, you have to think about this, because otherwise you have a problem, because you leave that independent from the other things you are doing. So I think it's very important to do this.
Thanks for the answer.
Yeah, no problem. You're welcome.
So one more question. Actually, no. So we can move to third presentation, and I see already in chat first question to Julia. Are your modules physical?
Yeah, so that I would say that's a yes and no question, because what we're maintaining is obviously something physical, but the maintenance action itself is not necessarily physical. And so I think the way to think about it is similar to maybe service modularization, more that the actions that we're taking and all the decisions that we're making in designing sort of or developing our maintenance and deciding everything that we need to do. It's not physical, but of course the maintenance action itself is physical, and it's happening because some failure occurred in the physical world. Yes.
So Thank you for your answer. One more question. So if no, I have one.
Yes.
Does your approach take into account the feedback between the collection of maintenance information and the development of new generation of product or service? So it's actually actual, your approach for current existing system, or you can collect, analyze this information and use this information for development of new generation of product, for example.
Yeah, specifically the work that we've been doing so far has been on existing and even pretty old aging assets. And so how are we able to improve the work that we do to sort of prolong the life of these assets that we already have? But we have been getting definitely some interest, and it's going to be, I think, a big area in the future of designing for maintenance and being able to weigh sort of two design options based, of course, on the investment cost, but also now that we have all this maintenance data, we could maybe also say something about the operational costs of having one solution versus another. So that's definitely a very interesting and upcoming, I would say, research area in this way of working.
So the second question from my side, it will be interesting for me, what your experience show, which of the three dimensions, physical, action, or process, considered as the most documented from people?
So action is definitely the least, because there's this free text formats that they use. Maintenance is a very traditional subject and has maybe no one has really been working that hard, at least in the industrial companies that we've worked with, to sort of scale the solutions. Between process and the physical, I would say the physical, at least because we need a lot of these facilities have a lot of environmental and safety considerations where there's a lot of legislation around. And so they need to document everything that's out there. It's just a matter of how collected is this documentation, right? So what we've worked with are these piping and instrumentation diagrams, but the company, fortunately for us, also has this breakdown of the technical system. So probably physical has been the easiest dimension to work with in that regard.
Okay, thank you. And also some additional small question to this topic.
Yes.
What about quality of this documentation, quality and quality assurance of this documentation, because it's also important for analysts.
Absolutely, and maintenance now is an area where there's a lot of artificial intelligence and machine learning, but from the standpoint that we have as design engineers, I would say we see because the quality is so bad, you still need the human interacting with the data, because it's not all the information is never going to be there, or at least for these older aging assets, it sits a lot with the people more than it sits in the documentation and in the data. Yes.
Okay, thank you, Julia, for your answer. One question from another participant. Okay, so let's move to next presentation. Maybe somebody have question to our presentation. Okay. So of course I have someone. Firstly, it's interesting for me. You organize some interview of survivors. How well the interviews showed, so people who you ask should understand the structure of the product and have knowledge of the product modules.
Yes, it was a bit difficult for them to understand the structure because not all of them were product designers. Some of them were graphical designers or service designers, and there was a lot of makers too. So the relationship with the product has a technical and development aspects were not really high. So it was a bit difficult for them to understand and separate what the modules were of each case. So in this case, they told us in the feedback that the guide was really helpful to differentiate the modules of each product. So it is a challenge in the continuation of development of the method, but we know that the guide is really helpful.
Okay, thank you. And some additional questions from a little bit another point of view. How would you describe the requirements for selecting people? So you should prepare some representative sample for some survivor. So what about requirements for selecting interviews to create a sample that guarantee result with some good level of significance?
Yes, it was a bit difficult at the beginning because we did a first selection of 50-60 people, and it was half makers and the other half designers. In the case of makers, we did a lot of interviews in person with these people, so we knew that they have enough experience in the maker field to do the survey. In the case of designers, we select the majority of them like product designers, and they was teachers in the university or people who have his own design study, and they have a lot of experience designing products. So it was a bit difficult. Of course, not of them answered the survey because the selection was 60 people, and in the end it was 24. But we ensure that all the people that receive the survey has enough experience in the maker and in the design field.
Okay.
Thank you.
Thank you. Thank you, Laura, for this answer. Another questions? Okay, I also cannot find new question in chat, so we move to the last presentation, and I have also a question to Tobias. As I saw, regardless to the complicated of product being compared, your approach is also quite comprehensive, quite complicated, I think. And speaking about the scheme of the proposal approach and steps 1 and 4, I mean slide number 5, I think, with 4 steps. Some data should be collected and evaluate. What should be, let's say, the accuracy of this data? Do you need some exact number of variants, for example, of product or numbers of function? Or are we talking about some certain number, taking into account some confidence intervals, for example? Or is it possible, for example, to use something like fuzzy logic?
Yeah, thanks for the question. So in the ideal world, obviously, we would love to have very accurate data. Yeah, the problem is most of the data we would like to compare is actually confidential, especially when we're talking about trucks or like really big investment goods like airplanes or something like that. there's nearly no way in getting the data. And if, let's say, we got access to some of the data or some insights at least, then those are not publicly available, and they cannot be compared to each other. So they're basically worthless for like real research, and because if we publish just the result, then nobody can basically confirm we didn't make an error. So in the end, we agreed to basically choose data that is like really publicly available, although we know that that data is not that accurate. It's more like the development of the data is more what is interesting for us there, rather than the absolute value of the data, if that makes sense to you. So we're more interested in how it developed, and what's the general direction of changes, rather than the actual number itself.
Okay, thank you very much, Tobias, for your answer. Another question to Tobias, or maybe to another presenters.
I have a general question. It's related with my investigation, and it's for all the presenters. I'd like to know what's your opinion or your point of view about the currently relationship between the end user and the modular design. Because in the context, we see that modular design has evolved a lot in the manufacturing, since the point of view of the companies. But what happens with the end user? I want to know what's your opinion about it.
I would have an opinion, at least, regarding that. In the projects I'm working with, we have got very similar problems, like complete different industries and business cases, but the problem itself is quite identical, I would say. The user, the end user, would like to have a product that is very cheap and extremely individual, very much optimized for his or her use, which is very much the opposite of modularization and standardization. So finding somehow like a break even where the company still gets benefit from it, so they can standardize some things, get some savings in the modularization, while the end user still has the feeling of getting an individual product, or at least the disadvantages for the end user are not that severe that they would pay more for an individual product. I think there's like a very small border somewhere in between. Yeah.
Don here, I agree what Tobias says, but what we did in our project with a train coupler, when we did the qualification of the modular system, we invited the customer to participate during the qualification. First, we did all the tests. Then we invited one of the customers, and he participated with all his quality people and followed us. And after that, he put an order that was you could say a letter of intent that they wanted to have for all their trains for 5 years. They wanted to have the train coupler. So that was a good success, I would say. That's one comment.
Thank you for your response.
So thank you. Does anyone have another open questions to the topic of our discussion? So, okay, if not, I want to say thank you for all presenters again for preparation of this video, and also thank design team and Fanica for organization of this of design conference and work in this section. I wish you all good evening. And I invite you to join the social event room. I think it will start in 5 minutes. So, thank you very much.
Also, thanks to you. Thanks to you.
Thank you.
Thank you to
It's
you
a
all.
pleasure.
Thank you all. Thank you.
Thanks, everybody. Take care.
Enjoy the rest of the conference and see you together down.
See you.
See you.
Bye.
Bye.